This summer, I wanted to try a personal project. I was always fascinated by decorative lights, but normal light ropes are pretty simple. I mean, there isn't much you can do with them. I wanted something more large scale, like a whole lights display capable of being custom programmed to show different images. Well, to try my best abilities, I first decided to do a 10 by 10 display with 100 LED lights. First, I took a wire string, then made a square frame out of it, then attached 10 more vertical and 10 more horizontal wires. Initially, I planned to give individual wire connection to every single light, which meant that I had to attach 10 additional wires to every row of the grid. Kinda tedious, and looks messy. Then I realized that my grid is very small. This is what it looks like compared to an average size hand sanitizer bottle. Not very impressive, so I had to dump that idea altogether and start from scratch. This time, I got a wooden photo frame and used it as my foundation. Analogous to previous grid, I attached 10 vertical wires and 10 horizontal wires to it. This one looked a little bigger and more impressive than the last one. Next step was to get the lights. Initially, I ordered a lights rope and planned to detach every single light from it, then solder them to my grid. But why do so much work if everything can be simpler? Instead of that, I then ordered a pack of 100 LED lights. I only had to solder them to the grid. I decided to dump the idea of every light having individual connection because it required too many wires and just looked messy. Instead, I decided to solder them to the grid wires directly. I soldered about 4 of them and realized that the grid didn't look impressive again. The lights seemed too large and the grid too small, and overall the entire thing looked a little ridiculous. Oh well, it was time to bring out the big guns. I got 4-meter-long wooden sticks and connected them together to make a frame. Then same work. I had to attach 10 vertical wires, but this time, instead of 10 horizontal wires, I attached 30 horizontal wires, because each LED light has 3 color connections and 1 ground connection. Then I had to solder each light individually to the grid. As I was running short on time, I decided to solder only the ground connection and 1 color connection. It was the color green. Overall, this grid is much more impressive than the previous ones. It's larger and easier to work with. After soldering, it was now time to bring the entire system together. To be able to control the lights, I used a Rasberry Pi microcontroller. The problem was that it didn't have enough available pins to connect all the necessary wires. To combat this shortage, I had to use 2 4-to-16 decoders. To put it shortly, by having only 4 inputs, these decoders can produce 16 outputs via binary logic manipulations. Essentially, they allow you to control 16 devices by having 4 input wires. I used 1 decoder for the ground connections and 1 decoder for the color connections. Now it was time to code. First, I decided to write a simple program to check if all connections are working properly. The program was supposed to light up each light for a half second in a rhombic shape. I was happy to find out that all connections are working properly. The program itself was a little boring though, and I realized I faced another challenge. I didn't really know how to make multiple lights turn on simultaneously. See, like I mentioned, I dramatically reduced the number of wires by giving up on the idea of every single light having its own connection. This meant that each horizontal wire in my grid had 10 lights attached to it. Not great, but I started experimenting. I reduced the time interval between the light turn-ons in the rhombus program. Now it looked better and more entertaining, sort of like a running cursor. Then I reduced the time interval even more and more until eventually I got to this, a static rhombic shape. But it's not actually static. It's still the same rhombic cycle, but with an interval of 1/1000th of a second. Our eyes just cannot perceive such a small interval, so we see a static picture. This was the key to static image. After that, I wrote this more complex program. Now I have to leave for college, so I didn't have time to do more. But I have plans to develop more complex software that would be able to convert pictures to my lights display. Thanks for sticking by.